Okay, Assalamualaikum warahmatullahi wabarakatuh. So we are going to discuss the answer for this question. Okay, beam analysis of beam using stiffness matrix method. So there are three elements. So we will have K1, K2, and K3. Okay, this is not the answer yet. This is K1, K2, and K3. This is not the answer yet because I just copy the format. Okay, so let's okay, start with draw the sketch the diagram for unconstrained and constrained degree of freedom. Okay, so we have one for unconstrained, one for constrained. Okay, for constrained system, we have 2 at A. We have 1 at C. We have 2 at D. And we have remaining 3 at B and at C. Okay, this is for the label. So we have to label, start from unconstrained, constrained, degree of freedom. So we start label with 1, 2. This is rotation. This is the arrow. 3, 4, 5, 6, 7, and 8. Okay, so for K1, the label will be 4. It is 4, 5, 4, 5, 1, and 2. 4, 5, 1, and 2. So start with label degree of freedom first. The degree of freedom must be labeled according to unconstrained and constrained. Constrained means support. Constraint means support. Okay, there are 2 at A, 1 at C, and 2 at D. Okay, so we have 5 degree of freedom in constraint system and 3 degree of freedom in unconstrained system. We label start from unconstrained 1, 2, 3, then followed by 4, 5, 6, 7, 8 in constrained system. Okay, when we label K, we have to label element by element. Start with YZ, YZ, YZ for near end. The left side is the near end, the right side is the far end. So we have to label K1 as 4, 5, YZ, and 1, 2. 4, 5, 1, 2. That is the label for K1. The label for K1. And we will calculate the K value. The K value for beam, it is 2 EI. It is 2 EI. The length is 3 meter. The length is 3 meters, so we get 0 point. The length is 3 meter, we get, in terms of EI, we get 0.889. And then we get 1.333. 1.333. And then negative 0.889. Then 1.333. $2.667. I don't think you have to spend for 20 minutes just to calculate this value. 667. Negative. This is just based on the formula given, negative 1.333. And then 1.333. Okay, next value is 0.889 and negative 1.333 and 2.667. 2.667. Okay, that is the K1. K1. Okay, K1. We move to K2. For K2, the label will be 1 and 2, 6 and 3. 1, 2, 6, 3. The label. It is 1, 2, 6, 3. 1, 2, 6, 3. Label DOF. This is compulsory. 1, 2, 6, 3. 1, 2, 6, 3. Okay, the length is 4 meter. EI. So we will get the first value here will be 0.1875, 0.375, negative 1875, 375. 1 is 1, negative 0.375, and then 0.5. 0.5. 1875. 1875, negative 375. And 1. And the value, you can see that there are only 1, 2 value, one different value, 0.1875, one value, 0.375 and second value. Okay, and then 0.5 and 1. So there are only 4 value in the matrix actually. Okay, so we must label. This is compulsory. Label must be according to YZ for near and far end. Near and far end. Near end means if it is for BC, near is B, far is near is B, far is C. That is why the label we use is 1263. 1263. The label. Okay. That is K1 and K2. K1 and K2, and actually, for K3, you will get the same answer because the length, the EI and the length is equal. Means for K3, it is the same answer. Okay, for K3, it is actually the same answer, but the label is different. This is K3. Okay, for 3, at C, the label is 63. At D, the label is 78. So it is 6378. 6378. It is 6378. Next week, for class session, for physical class session, if you don't prepare, you just don't come. If you don't prepare your mind to get the knowledge, then you just come and waste your time. You won't understand. Because this is actually very simple thing. And you do not know how to do it. You just have to substitute the simple value into the formula, and you just cannot calculate it. It is simple matrix only. Okay, so we have 3 value because we have 3 elements. We have member AB, member BC, and member CD. Okay, you will be given the formula. You don't have to for beam analysis, you don't have to put coordinate. You don't have to calculate Cx, Cy. The K value is only depending on EI and L. Okay, it is 4 by 4 matrix because of two degree of freedom per node in Y and Z direction, and for A, B, A is the near end, B is far end, left is near, right is far. A, B will be the far end. So we have to label Y, Z start from A 4, 5, 1, 2. But the label, we must label it according to unconstrained and constrained degree of freedom. So that is why you have to sketch. You have to sketch unconstrained and constrained. Constraint means no movement. Constraint means support. So if it is support, so we can be able to identify the degree of freedom for constraint first, because we look at the support in the diagram. Okay? And in B, we don't have to consider X. That's why we only count 2 at A, 2 at D. Even though it is fixed N. Fixed, we know that there are 3 unknown reactions in X, Y, and X, Y, and Z. But since B, we don't have to count X, so we count as 2. Y and Z at A, Y and Z at D, we put into the constraint system. And another reaction is at C, Cx. So sorry, Cy because it is pin support, even though pin has X and Y, but we don't have to count X, so we only count Cx. Because at A, there are AY and MA, moment at A and AY, vertical force, vertical reaction at A. That is the thing that we are going to analyze at the end of analysis. We have to calculate what is AX value or AY value. We have to calculate what is moment at A. We have to calculate what is CY value. We have to calculate DX, DY value. We have to calculate MD value. We have to calculate the reaction at the support using stiffness method. The question is the same. We have to calculate the reaction. The reaction at the support. There are 3 types of support. There are 3 support at A, at C, and at D. We have to count 2 at A, 1 at C, 1 at D. So there are 5. So these 5 unknown reaction represent 5 degree of freedom in constraint system. And you have to label that. You have to sketch. Just sketch. You don't have to draw it very slow, put everything inside. No, you just have to put a line and put the sign convention and label it. That's all. I don't think you need 20 minutes for this, and still you don't finish it. But what most important is you have to label it correctly. You have to label YZ, YZ. If you don't label, then you cannot continue the process. Labeling is very important. It look like easy, but if you don't prepare, so always have students who do not know how to label this correctly. Every semester. Even though this is very simple question. Then you have to plus all K1 plus K2 plus K3 to get the stiffness matrix, and it is 8 by 8 because ABCD is 4 joint. ABCD is 4 joint, 4 times 2 is 8. So it is 8 by 8 matrix. It is 8 by 8 matrix. You are wasting your time if you don't get ready before coming to the class. Just wasting your time, just wasting your semester. And at the end, you have to repeat. That's not the joke. This is the fact. If you don't have set your mind inside the class, so you better don't come. Because you're just wasting your time. Okay, 1, 2, 3, 4, 5. 6, 7, 8. Because 8, we have 8 degree of freedom. 8 degree of freedom. A, 2, B, 2, C, 2, D, 2. So we have 8 degree of freedom. And from K1 and K2 and K3, it is just simple mathematics. You plus the value only. 1, value for position 1. So the label, the red label that we put in K1, K2, and K3 is actually representing the position. Degree of freedom means position. Displacement, that is position. Okay, representing position 1, 2, 3, 4, 5, 6, 7, 8. 2 at each joint. Okay, so when we want to calculate 1, 1, 1, 1 means we have to find the value 1, 1 from K1, K2, and K3. That is the simple mathematics. And you have to try to do it within the time given. It is just about 5 minutes, not more than that. And actually, you don't have to give, yeah?
Untuk yang metrik 33 dengan 88 tu 0.1 ke 1?
Which one?
K2 dengan K3.
K2 dengan K3, 1-1.
Okay, thank you.
Okay, so you have to practice to do this within 15 minutes, not more than that. If not, you will take time from the other question, and at the end you cannot finish the question, the answer. You cannot finish in final exam. You cannot do. That's why practice is very important. And you have the video, right? The link, the Telegram, I have put all the link inside. So please watch before you come to the class. This is confirmed. Beam, frame, and truss. The beam question is, okay, please look at the past year's exam paper. For maybe for 10 years ago, see the trend. Beam question for stiffness method. If you can do this, you can pass the exam. If you cannot do this, you will fail the exam. Okay, 1, 1. You just have to plus the value, right? So why so long you take the time? 1, 1. 1, 1. Don't have 1, 1. So it is 0.889 plus 0.1875. What is the answer? What is the answer? It's EI, not EA. EI. What is the answer? 0.889 plus 0.1875?
1.0765.
1.0765. 077, eh? Okay, 3 decimal places. Okay, 1, 2. 1, 2 value. 1, 2. 1, 2. This. 1, 2, this.
1708.
1708. 1.708. 1.708. Okay, 1, 3. 1, 3. 1, 3 value. 1, 3. We only get from this 0.375. 0.375. 0.375. Next value 14. What is the value 14? 14 for 1 is the same.
Negative 0.889.
Negative 0.889. Okay, 1415. 15. 15 is 1551 is the same.
Negative
1551.
1.333.
Negative 1.333. Negative 1.333. Okay, next one 16. 1661. 1661 is the same. 1661. Negative 0.1875. 1718. 1718. 0 and 0. 1718 0. When you cannot find the value, when you cannot find the position, means the value is 0. When you cannot find the position, there is no 1718 in K1, K2, and K3. The value is 0. Okay. Next value is 22. 22. This is 22. Another 22 is here. It is 3.667. 22. Then 23. 23. 0.5. 0.5. 24. 42. Okay. Please do it together with me because you have to submit this at the end of this session. It is 1.333, yeah? Okay. There is 22, 23, 24, 25. What is the value for 25? 2552 is the same. 2552 is the same. Just a simple step.
1.333.
Okay, just a simple step. But if you don't do exercise, you cannot do. 26, 27, 28, 26. 26, what is the answer? 26. 6226.
Negative 0.375.
Negative 0.375. 28, 27, 28. 0 and 0. Then move to 33. Move to 33. It is 1 and 1. 33, yeah? 1 and 1, right? So it is 2. And then this is 3, 3, 3, 4. 3, 4. 3, 4. What is 3, 4 values? Value 0. 3, 4, value 0. Okay, 3, 4, 3, 5. 3, 5. 3, 5. If you don't find the position, that is 0. 3, 5. 3, 5. 0. 0. 3, 6. 3, 6. 3, 6, 6, 3. 3, 6, 6, 3. 0.375. 0.375. Next, 36, 37, 38. 36, 37, 38. Negative 0.375. 37, 38. 37, 38. 38 is 0.5.
Doktor, yang 63 tu bukan negatif 0.375 tambah negatif 0 point ni ke?
Ya, kena tambah. Kena tambah sini ya. 63. Okay, what is the answer? 63? 0. What is the answer? 63. 63 sini, 63. So 0 eh?
0.
Okay, 0. 63, 67, 68. Okay. Okay, next is 4. 4, 4 eh? 4, 4. Okay, 4, 4, 0.889. 0.889. Next is 4, 5. 4, 5, 4, 5, 1.333. 4, 5. 4, 4, 4, 5, 4, 6. 4, 6, 0. 4, 7, 0. 4, 8, 0. 0 whenever you do not find the position in K1, K2, and K3. Means there is no intersection. 5, 5. 5, 5. 5, 5. 2.667 eh. 5, 5 is 2.667. 2.667. 5, 5. 5, 6, 0. 5, 6, 0. 5, 5, 7. Can you find 5, 7? No 5, 7. No 5, 7, no 5, 8. No 5, 7, no 5, 8. 0, 0. And then 6, 6. 6, 6 you get from 2. 6, 6 this and 6, 6 this. Okay, so the value is 6, 6. What is the answer? What is the answer?
0.375.
0.375. 0.375. Okay, it is 6, 6, 6, 7. 6, 7. 6, 7. 6, 7, negative 0.1875. Negative 0.1875. 6, 7, 6, 8, 0.375. 7, 7. What is the answer? 7, 7. 7, 7 is 0.1875. 0.1875. 0.1875. 7, 8. 7, 8 is negative 0.375. And 8, 8 is 1. 1. So this is the K, the stiffness matrix for the beam, for nodes, for joint. Okay, you have to practice to do this, not until 30 minutes just for doing this, cannot. Okay, so this is the structure, the element global stiffness matrices K1, K2, and K3. Element global stiffness matrices. Because we are referring to the global coordinate system. That is why we call this as element global. Element because it is 4 element, 1 by 1 element. Element 1, element 2, element 3. And after that we combine to have the structure stiffness matrix. Okay, the structure stiffness matrix is 8 by 8. That is why in introduction previously, the concept of stiffness method, when we want to calculate K, to establish the K value, what we have to do is we have to divide the structure into element. Why it has that statement? Because K, we can only get the K value for the structure, for the beam. Okay, from element stiffness matrices. We cannot get directly. So we have to divide the structure into element. That is what, okay, what we do right now. We have to divide structure into element. We divide into K into element 1, element 2, element 3. We divide into element. Then we combine back to have the structure stiffness matrix. If you produce wrong K, of course you will get wrong displacement and wrong reaction at the support. Okay, you have to make sure that you label it correctly so that you get the right K value. Okay, that is K. The structure stiffness matrix, the beam stiffness matrix. Okay, after that, looking at the diagram, because in beam analysis we have to have normally UDL. UDL means there is loading on the member, and always remember that for stiffness method, we can only calculate the value, means displacement and forces at nodes. And in the textbook actually, there is one part in the textbook telling us how we identify nodes. Okay, for example, when end of the structure is node, A and D is node because it is end of the structure. Support is also node. That is why C is node. Support is also node. The first and end of the structure, A and D is are nodes. Node A, node D. C, support is also node. That is why C we consider as node. C is node. Support is node. Beside support and beside end of the structure, because we also have cantilever end, beam with cantilever end. The end cantilever is node. So in the textbook, there is one part telling us about how we identify nodes, and I have video also explaining about this. Okay, and that is the two reasons, two things how we identify nodes. Another thing, we have to declare that point as node is whenever the beam has this changes in the cross section. Between EI to EI and EI. Changes in cross section. Because the I is moment of inertia. Moment of inertia relate with cross section, the size of the element, the size. So changes in size also we have to consider as node. That is why B is node. And another thing is when there is a loading at that point, and we want to know that deflection and rotation, for example, at that point. Because at B, if we want to at B, if we declare B as node, okay, for example, AB ni dia it is EI also. There is no changes in cross section. But we have B. We have loading like this. We can also declare it as not even though AB and BC have same cross section. Because it depends on us. If we want to calculate displacement at that position, then we have to put it as not. Okay, but for this question, it is very clear that B is not because of the changes in cross section. The changes in cross section means we have to put not there, and and also C is declared as node because of the support, the pin support. So we have to put it as node. So in total, there are 4 nodes. There are 4 nodes. Node A because of N of the structure and support. B because of the changes in cross section. C because of the support, even though it is internal, so that is node, as well as the loading, due to the loading at C, because there is a moment at C. So because of the loading, we want to determine the deflection, the rotation at that point. So we have, okay, and D is support. If D is cantilever, it basically for consideration. Okay, so that is the concept, that is the theory, and you have to understand about that. Okay, so there are 4 nodes. There are 3 elements, K1, K2, and K3. So it is beam. We know that beam has 2 degrees of freedom per node in Y and Z direction. We don't have to count X because in beam, the X value is always 0. There is no horizontal force value. There is no horizontal displacement value. So that is why we don't have to consider the X component. So degree of freedom for beam is always depending on Y and Z. And this Y and Z, we must be able to look at it in terms of displacement, D, displacement, and forces, Q. Okay? So degree of freedom, YZ, the YZ component is very important. Okay, so yang ni label just by following the formula, but the label is very important and produce the structure stiffness matrix. Only after we have this K, we can calculate the displacement and reaction at the support. Okay, so looking at the beam. Okay, BC, AB settle because AB has no Q naught. Now we are moving to equivalent nodal forces. Equivalent nodal forces. Equivalent nodal forces means we have to distribute whatever force that is subjected on the member to nodes. We have to distribute to A, we have to distribute to B if AB is subjected by loading. But when there is no load on AB, so we don't have to calculate it, okay, because the value are 0. Okay, same goes to CD. Same goes to CD. CD, there is no force, there is no point load that is subjected on the member. So it is 0 as well. But the UDL, we have to distribute to node B and node C. The UDL, we have Q is equal to KD plus Q naught for beam analysis. Q is equal to KD plus Q naught. What is Q naught? Q naught is equivalent nodal forces. Why we call it as equivalent nodal forces? Because we have to distribute the loading equivalently. Okay, and in this case, it is equal because it is UDL. UDL just a rectangular shape. So it is symmetry. So that is why we get moment at B and moment at C by using the formula fixed end moment, fixed end reaction, we get same value because it is symmetry. Okay. So it is Q1 naught here. Okay, we have 3 Q1 naught, Q2 naught, and Q3 naught. Q1 naught. Okay, remember this is equivalent element nodal forces. Equivalent element nodal forces. The label is not for the equivalent nodal forces. Okay, 1 for element number 1. And it is 4 by 4 matrix, 4 values. from 4 position. From 4 position. And the label we have to follow the label we use here for the K. So it is the same label. It is the same label. It is the same label. Okay, it is 4512. We use in K1 4512. We use the same for Q1 node. And the value is all 0. Because on member AB, there is no load. There is no load. On the member, not at join. On the member, not at join. If there is a load at A, load at B, it is Q, not Q naught. Bukan Q naught. If there is point load, that is subjected directly at A or at B. So that is Q, not Q naught. Or moment. Okay, so Q1 not 0. Q1 not 0. Okay, Q2 not means we need to refer to member BC. Member BC. Member BC has UDL 30 and 4 meter length. Okay, the label first, the label will follow K2. The label will follow this. The label will follow K2. Okay, the label will follow K2. 1263. 1263. So what we should do here, we just need to draw the, okay, this is given in appendix, the fixed end reaction. And always remember, fixed end moment is behavior. Behavior 30, 4 meter length. The moment will react always like this. It depends on the loading. Loading on top of it. It will bend. The moment will counter back. That is why the direction of moment is like that. It is not assumption. It is behavior. Fixed end moment. And also the vertical reaction. Vertical reaction. Okay. Vertical reaction. So all this formula to calculate the vertical reaction at support and the moment at support is given in appendix. However, it is very straightforward. Okay, WL over 2. WL 30 kali 4, 3 kali 4, 12. 3 kali 4, 12 over 2, it is 60, right? This is 60, right? WL over 2. Is it right?
Yes, Doctor. Yes.
Okay. WL squared over 12 for the moment. What is the answer? W30
40.
is 40. Okay, then you have to have another diagram to just to compare the, because they are to compare the position. So this is near is and far. Means that this is B and C, right? So at B we label as 1 and 2. This is 6 and 3. Okay, 1, 2, 6 and 3. So that is the this is actually referring to this that position. 1, 2, Y, Z for B. 6, 3 is Y and Z for C. So now why I have to draw this to diagram? Because it is easy for me to compare and put the value in K2 not Q, not K, Q2 not. Okay, so we just need to compare and put the value. Okay, so what is the value for position number 1? Remember, DOF is the position. What is the value for position number 1? By comparing these two diagrams, what is the value?
60.
It is 60. 60. Okay, next. Position number 2, what is the value?
40.
40. 40. Same direction means positive. Opposite direction means negative. Okay, 6. What is the value?
60.
60. Okay, at position 3, what is the value?
Negative 40.
Negative 40. It is negative because these two diagram has opposite sign. Opposite sign. Same sign, positive, opposite sign, negative. Okay, opposite sign, negative. Because the orange diagram, okay, is the sign convention we use for stiffness method, for the formula. Okay, so we have to follow that sign convention. Okay, this is Q2 naught. This is Q2 naught. Actually, if you don't want to write Q1 naught, also okay. Understood that you understand it because it is 0. We only calculate the value for Q2 naught. That is okay. Okay, so Q3 naught also the value is 0. Okay, moment 450 that is subjected at C is Q. Q, not Q naught. Bukan Q naught, it is Q, nodal forces that is subjected directly at nodes. That is why 450, okay, is not included in this Q naught because it is nodal forces, not equivalent nodal forces. Okay, so because there are 3 degrees of freedom in unconstrained means there are 3 unknown displacement. 3 unknown displacement. D1, D2, and D3. 1, 2, and 3 unknown displacement. 1, 2, and 3. And you have to look at the component. 1, in terms of displacement, 1 means vertical. Compare vertical deflection at B, that is 1. D1 is vertical deflection at B, D1. Because 1 and 2 is actually at position B, 1 is Y component, so D1 means vertical deflection at B. As I mentioned last week, we have to be able to read the symbol D and the symbol 1 that we label based on the right behavior. It is D1 equivalent to vertical deflection at B. Of course, logically sini dia akan ada like this, right? Due to loading and due to the cross section. Of course ada deflection at that point. The vertical deflection. So here will have delta B and theta B. And at C, there is no vertical movement. At C, there is no vertical movement because of the pin support. But it has rotation. So at C, it has theta at C. So at B, there are delta at B and theta at B. This actually represent 1 and 2, D1 and D2. And 1 and 3 means rotation at C. Because pin has rotation. Peaks do not have rotation. Okay, so 1, 2, and 3 means we want to calculate vertical deflection at B, rotation at B, and rotation at C. That is D1, D2, and D3. Okay, So we put into the stiffness equation. Stiffness equation. So why we only have to write this? Because we solve, because the rest are all zero unless there is a support settlement. Okay, if support settlement is given in the question, then you have to consider that. Okay, in this question, I put the support settlement. But, okay, okay, let's solve this first without support settlement. And after that, we include support settlement and we see what is the difference in terms of displacement. Okay, so 1, 2, and 3. 1, 2, and 3. Look at back to this. 1, 2, and 3. So this degree of freedom, position 1, 2, and 3. Tadi D1, D2, D3 kan? Tadi D1, D2, D3. Delta B, theta B, and theta C. Now, 1, 2, 3, in terms of forces, 1, 2, and 3 means Q1, Q2, Q3. What is Q1? What is Q1? What is Q2? What is Q3? From the figure. From the figure. Q1,
Zero.
what is, okay, Q1 is 0 because there is no vertical load directly at B. Okay, what is Q2? Q2?
Zero.
What is Q2? Q2 is also 0. Q2 represent moment at B. Q2 represent moment at B. So sini B, right? This is B. This is C. Okay, Z in terms of Q is moment. And there is no moment at B. What about Q3? What about Q3? What is the value? Q3. What is Q3? What is the meaning of Q3?
Negative 450.
Okay. Q3 is moment at C. Q3, because it is that component, it represents moment at C. And the moment given is clockwise. Remember, the sign convention is counterclockwise. If we compare these two, it is opposite. Okay, compare the label that we put at C in the unconstrained system, opposite with the moment that is subjected at C. So it is negative 450. Negative 450. So this is the stiffness equation. It is 0, 0, and negative 450. Okay. Then we have to copy the K value up to 3, 3. 1, 1. Okay, this is 1, 1. This is 1, 1. Dia senang tau. And ramai student menyesal bila esok nak exam, dia faham very well tapi because tak cukup exercise, dia tak boleh buat exam. Bukan tak tahu buat. Bukan tak tahu jawab exam. Dia masa tu at that time dah boleh buat dah faham dah masa tu. Sebab apa faham? Sebab memang get ready. You have no choice, you have to get ready. But you don't get ready during the class, cannot. If you get ready before you enter the class, so you actually get ready earlier. You practice earlier. When you get ready before examination, the day before examination, a week before examination, at that time you will understand all about this. But because lack of exercises, you cannot do in final exam. So every semester ada student yang akan cakap macam tu. So it is very sad lah, because actually you can score if you put your effort early, not the day before exam, a week before exam, cannot. It's just a simple stiffness method compared to the other is straightforward like this. You are so lucky I have removed topic number 3 from final exam. Previously, students have to answer 3 topics in final exam and they don't know which one to focus. I have removed one from exam so that you can only focus on 2 topics. So this is compulsory for you to know for final exam. Then you still want to play, eh? Don't take it seriously. You don't prepare at all. You don't prepare. You don't set your mind to receive whatever I deliver in class. You don't get ready. You just show me the blur faces before class, during the class session. You're just wasting your, because it is not easy. Actually, if you focus on stiffness method, you can have at least 50 marks. Target, you can get 50 marks from stiffness method. 50 marks or at least 40 marks. And then you top up with another 2 questions from flexibility method. Then you should pass. At least you get 50 marks in final exam, not 10 over 100. It is ridiculous you get 10 over 100 in final exam. Zero 0.5. It's your journey, not my journey. But I am the one who actually very sad every time student cannot do in their final exam. Just the simple operation like this, takkanlah tak boleh buat kan? Okay, benda ni so simple, just a simple mathematics. The concept is structure, but the solution is mathematics. Okay, EI, if EI is not given, so let the answer in terms of EI, D1, D2, D3. So this is K, and can I put at the right position the value just now? Sini tu. 0.5, 3.667. Okay. Okay. So this is the K value. You pergi dengar balik VC cakap apa. Ilmu ni rohani tau. Kalau you tak prepare, you tak sediakan your rohani dalam kelas, you badan je kat situ, fizikal je kat situ, tapi you tak prepare pun. Mentally tak prepare pun. That's why I say, if you don't get ready, you just don't come. But you tak ada kat situ pun. Jasad je kat situ. Okay, D1, D2, D3. 450, tadi yang tu. Okay, this one is Q naught, This is Q naught. Q naught 1 to 3. Q naught 1 to 3 we get from Q2 naught 160 to 40. 3 is negative 40. Okay, 1 is 60. Actually kalau ikut saya dekat-dekat, you buat latihan hari-hari, tak faham, you tanya soalan, you mesti boleh dapat at least B. At least B boleh dapat. Sebab siapa yang ikut saya rapat-rapat? Tak ada kan? Tak ada rasa nak buat pun latihan. Okay, so this is 1, 2, 3 come from this 1, 2 and 3. 60, 40 and negative 40. Sebab we only have the value from element number 2. We don't have value for element 1 and element 2, element 3. Okay, so this is the stiffness equation that we use to calculate the displacement, displacement D1, D2 and D3. Displacement can be rotation, displacement can be vertical displacement or deflection. This D1, D2 and D3, okay, depending on the position, so some will be the deflection, the deflection, some will be the rotation. Okay, so this is compulsory. Without this equation, you cannot get the answer. So target every time you want to analyze the beam, for example, to calculate the reaction at the support, reaction we calculate from displacement. Displacement kena dapat dulu. Displacement kena dapat dulu, baru boleh dapat reaction. That is why reaction ni label dia 4, 5, 6, 7, 8. Sebab kita akan dapat from the stiffness equation 1, 2, 3 dulu. So yang datang dululah kita label dulu. That is why we label unconstrained 1, 2, 3. D1, D2, D3. Kita tak nak calculate kita tak naklah label dia last. Kita just label je 6, 7, 8. Kira dulu D6, D7, D8. Memang boleh tapi kita tak nampak dia punya flow tu. So the beautiful flow dia tu is because kita nak cari displacement first baru dapat reaction. Without displacement, we cannot get reaction. Without displacement, we cannot get reaction. So that's why bila kita label, kenapa label mesti label satu dekat unconstrained. Kita tak label satu dekat constraint. Sebab di satu tu adalah unconstrained. Pada unconstrained ada movement. Movement tu is displacement. Displacement. D1, D2 and D3. Okay. So this is the stiffness equation. Simplify this. Simplify this. Okay. D1, D2, D3. Okay. It is negative. So bawa sebelah. 0 minus 60. Negative 60. And then negative 40. Negative 40, negative 450 plus 40. So we get negative 450, we get negative 410. Okay, so this is based on the calculator format. 3 unknown, what X, Y, Z. Based on the calculator format, EI is not given, so give the answer in terms of EI. So the answer per EI, the answer D is the answer in terms of D is per EI, not times EI. Okay, so use calculator. So at this point, you do not have to solve this manually using simultaneous equation. This is not mathematics subject. Okay, you just have to solve using whatever tools that you have and just write the answer, that's all. You don't have to do it manually. It will not give you extra mark for doing that. Okay, so key in directly into your calculator. three unknown. It is three unknown. D1, D2, D3 is X, Y, and Z. X, Y, and Z. A1. A1 apa? 1.077. A1. B1 is 1.708. Tu kenilai tu. C1 is 0.375. D1 is negative 60. .708. Next is 3.667. 0.5. Negative 40. 0.375. You just ikut je apa saya buat. You ikut saya rapat-rapat. You boleh buat macam saya buat. And that is what I hope. And negative 410. I'm sad, you know. Bila makin final exam, look like you don't, it just look like you don't learn. You don't learn. Takkan cukup setakat dapat 30 markah. Tak cukup. Jadi engineer kan? Negative 42. Negative 42.838. Negative 42.838 You kena nampak ilmu ni tinggi nilai dia. You tak boleh nampak ilmu ni macam alah tak apa, nanti lecturer tolonglah bagi pass. Tak boleh macam tu. Tak boleh setakat nak pass je, cannot. Pasal benda ni bukannya susah pun, you yang tak letak effort. Tak nampak pun effort tu. Datang kelas muka blur je seorang-seorang. 37.169. 37.169. Another one. Kunci dia cuma satu je, latihan. That's all. 206.26. Negatif. 206.26. Kalau you tak ready, you dah tak boleh drop kan? Dah tak ready. Kalau tak ready nak ambil, drop dah tak boleh. Bar je lah. Payah ambil. Sama je. You datang ambil exam dan keadaan you tak ready, tak ada effort, tak ada kemahuan, tak suka di subjek, you akan fail berkali-kali. Okay, that is the D answer. D1, D2 and D3. Okay, if you have EI value, so just substitute EI. So you will get displacement in meter for D1 and rotation for D2 and D3 in radian. So ni je. Solve using calculator. Okay, dapat D1, D2, D3. It is just 3 simultaneous equation. Tapi tak payahlah tunjuk simultaneous equation tu. Tak perlu. Okay. Then you have to substitute. Okay, substitute this D1, D2, D3 to answer the question. To answer the question. Soalan tadi minta calculate vertical reaction at support D. Calculate vertical reaction at support D. Okay, tengok pada support D, tengok apa label yang kita pakai. What is the label that we use at D? The position label. At D, vertical is Y component. What is the label that we use? So you just need to calculate one Q value. There are 5 value. There are 5 value and you just need to give one value out of 5. Okay? So look at the diagram. The first diagram that we sketch. Okay, at D we label as 7. The 7, position number 7. Position number 7 means that the dy is Q7. dy is Q7. Okay, vertical, it is vertical. Vertical reaction at D and we use 7. You ingat tau, kalau you tak bersedia masuk kelas, you tak letak effort, you tak buat latihan, you tak suka buat latihan, you akan repeat lagi. You akan repeat. You takkan boleh buat exam kalau you tak letak effort. Ini semua perlu pada effort. Bukan susah tapi kena ada effort. Tengok muka seorang-seorang dalam kelas pun dah nampak. Siapa yang faham, siapa yang tak faham. Siapa yang ready dengan siapa yang tak ready. Nampak everyone from your faces. Boleh nampak. Kenapa you nak bazirkan 1 semester, 2 semester, 3 semester. And at the end, you kena buat kali ketiga. Nak tak nak kena buat. Nak tak nak kena pass. Nak tak nak kena ada juga effort. Kalau tidak, dismiss. Kenapa you nak pergi buat sampai 3 kali? Sedangkan you boleh buat dia sekali. Kan? You boleh set, kalau you malas sekali, you berajin sekarang, you settle sekaligus. You buat malas, kali pertama malas, kali kedua malas, kali ketiga. Tak boleh malas, dah terpaksa. You don't have choices masa tu. Mesti macam mana cara sekalipun mesti kena pass. So apa you buat masa tu? Kali ketiga ambil. Buat juga effort-effort yang selama ni you tak buat. Wasting time. So this is Q7 Q7. So dekat sini lah penting you faham konsep ni. You faham Q7. Q7 kat sini 7. Tapi Q7 tak ada nilai, ada satu nilai. Okay, this is Q7. This is 7. This is 7. This is 1, 2, 3, 7. Okay, 7 ni kita nak pakai dekat sini. Ini matematik Sebab kat sini position dia 7, 1, 7, 2, 7, 3. Okay? Ini matematik. 7, 1, 7, 2, 7, 3. Because 7, 1 kali dengan D1. 7, 2 kali dengan D2. 7, 3 kali dengan D3. So from this, yang kita akan pakai for the answer is 7, 3 only. Because 7, 1, 7, 2, 0. 7, 1, 7, 2, 0. 7, 3 je yang ada value. So 7, 3 ni kali dengan D3. So that is matrix multiplication. Q is equal to KD tu. So dekat sini, it is D3 only. Yang lain ni semua tak masuk. D1 kosong, D2 kosong. It is 7, 3. 7, 3. Value dia 7, 3. Negative 0.375. Tak nampak, usaha bagi nampak benda tu. Takkan sampai tak pandai nak tak pandai, tak nak kau tak pandai. You all bukan tak pandai. Tak ada usaha. Takkan tak nampak, you tak nak usaha bagi nampak. Matrik dah belajar daripada sekolah lagi kan? Tak boleh tak nampak, usaha bagi nampak juga. Benda ni. This is matrix multiplication. Matrix multiplication. Negative 0.375. D3. 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 EI. EI. Because EI ni nanti akan cancel dengan EI ni. Akan cancel. Okay. Okay, yang ni apa dia? Yang ni adalah nilai Q not at position 7. Kalau ada value, Q not at position 7, tak ada value. Q not at position 7, value dia 0. Q not at position 7, value dia kat sini 0. Okay, so we get this as negative 0.375 kali dengan negative 206.26. Q7. Q7. What is the answer? Negative 0.375 kali dengan D3 and D3 is negative 206.26. Kalikan dengan yang ni. What is the answer? We get positive. Okay, it is in kilonewton. What is the answer? What is the answer?
$77.348.
77.648. 77.348.
348.
348. Okay. So yang ni without settlement. Maksudnya D ni kita we get from without settlement. And then from stiffness equation we get vertical reaction ni without considering settlement. Without considering settlement. What if we have to consider settlement at C, at apa tadi? Soalan tadi? At okay, settlement at C at C 10 over EI at C. Okay, settlement 10 over EI at C ni means that tengok pada C, what is the label that we use? Tengok pada C, label apa? From 1 to 8 tu apa label yang kita pakai dekat C? Mewakili vertical direction at position C. Tengok balik diagram yang first tadi. That's why the first diagram ni is very important. We use 6. 6. It means that D6 is no longer 0. D6 is no longer 0. So we have to include D6 when calculating the displacement, the unknown displacement. Okay, yang atas settle Atas settle, yang ni kita nak masuk support settlement at C. What does it mean? Okay, support settlement ni berlaku pada support. Constraint lah pada support, constraint. Okay, dia kata dekat C, settle 10 over EI, 10 over EI dekat C. Dekat C tu, settle means vertical. Settle means vertical. Dekat C, vertical. Vertical memang ada pada C lah, pada constraint. Sebab dia support. Dia bukan ada dekat atas tu. Dia ada dekat ni. Sebab support settlement, nama dia pun support settlement. Constraint is support. So dia ada pada 6. And support settlement means D6. Okay. So yang kita dapat macam ni tadi. Macam ni. Kita dapat macam ni sebab D4, 5, 6, 7, 8, 0. No settlement. Kenapa dia tinggal macam ni? Sebab D4, 0. D5, 0. D6, 0. D7, 0. D8, 0. Because original stiffness equation, dia 8 kali 8. This question, 8 kali 8. Okay, but We only consider this because of displacement 0 in constraint system. Now, whenever support settlement is given, we have to include that. We have to include that. So dia punya proses, dia kan, you kena nampak dia in full. Okay, saya tunjuk kat sini in full dia nampak macam mana Okay. And you tak payah tunjuk pun. Ni just nak tunjuk dekat you all so that you nampak dia di mana. Tapi actually you don't have to tunjuk. You just have to imagine. Okay. So daripada mana kita dapat yang ni? Maksudnya dia from this. From this. Okay. Dia kan Q is equal to KD. So sini Q. Sekejap saya nak. Sekejap ni. So it is 8. Okay. Kan dia Q. Sini Q kan. Q. So yang ni yang full lah. Yang full. Yang mana you don't have to give. Benda ni tak perlu tunjuk. Tapi kena nampak. 5, 6. Ni 6. Q6. Q7. So this is the theory behind software. So you biasa guna apa? Esteem ke apa ke? So semua actually based on this theory. This is Q. And dia kat sini D. Kan Q is equal to KD, right? D. So sini semua D. That's the formula D. Sini D. Sini D. So yang D1 sampai this 8. This is come from Q is equal to KD. And dia ada plus Q0 kat sini. Plus Q0. Q0 tak boleh lah pergi gabung dengan D tu. Dia the other things. Okay, and Q0 ni selalu ada value dia lah. Value yang kita calculate. Dia tak ada simbol, dia semua value. Okay, ni semua value lah. Value yang kita calculate from. Yang tadi ni. Yang ni. 1, 2, 6, 3 ada value. 1, 2, 1, 2, 1, 2, 6, 3 ada value. So sini 1, 2, 60, 40, 60, 40, 1, 2, 1, 1, 1, 2. Lepas tu 3 negative 40, 3 negative 40, negative 40. Lepas tu 5, 0 value, 4, 5, 0, 4, 5, 0 value. This is the thing that you should be able to imagine. Benda ni. Kalau you tak nak imagine, susah lah. 6 is 60. 60. This is 60. Okay. So Q ni akan always ada value. Dia memang value kat sini. This is Q0. Q0. Q0 Q0 always dalam the full display, full equation. This is equation, stiffness equation. You tak payah tulis semua ni 8K8, 10K10 cannot. You don't have to write all. Tak payah pun. Tetapi you have to imagine this. Okey, apa maksud displacement at support? Displacement at support makna dia support kita label as 4, 5, 6, 7, 8. So sini 0, sini 0, sini 0, sini 0, sini 0. Sebab 5 tu support. 5 ni support. So semua 0. So what happen is when settlement is given at C kat sini referring to 6. So it is D6. So dekat D6 ni dah bukan 0 lah. Dekat D6 dah bukan 0 tapi value tu. So dekat D6 ni dah bukan 0 tapi negative 10 over EI. Kat sini 10 over EI. EI. Okay. 10 over EI. So yang lain masih 0 lah. Kecuali 1, 2, 3. 1, 2, 3 is yang kita nak calculate. So D4 masih 0. D5 also 0. D8 also 0. Anyway, dia akan depending kepada kat mana you label, what is the label that you use. Takkan sama setiap orang. Ada orang label dekat C tu 7. So you punya dekat 7 lah. Ada yang label dekat C tu 8. Dia dekat 8 lah. So my case dekat C tu 6. So dia dekat 6. So what is actually happen is bila kita nak solve yang ni. This is mathematic ya. This is mathematic. Okay, bila displacement 0. Ini yang pagi tadi pun saya dah explain. Sebenarnya dia punya proses in solving this stiffness equation to calculate the displacement D1, D2, D3, dia bukan kita consider yang 3 tu je, no. Dia sebab dia kali dengan 0 dia dapat 0. So that's why yang ni semua tak masuk sebab dia 0. Yang mana 0? Yang mana 0? Ni 0. Mana lagi 0? Sini pun 0. Tak, ni bukan 0 dah. Now bukan 0. Okay. Lagi 8 pun 0. Ini matematik ya. This is purely mathematic. Okay. Dia bukan hanya line, row also. Sebab dia kan matrix multiplication ni. Line times row. So this is 4. This is 5. This is 6, 7. Ini dalam your phone boleh tengok That is why bila ada settlement dekat C, so sini 6 Sini position 6. So value 3 ni kena include. Sebab ni value kita akan kali dengan ni. That's the process. Okay, that is the real process when solving unknown displacement using stiffness equation. Okay, previously when there is no support settlement 4, 5, 6, 7, 8, 0. That's why dia tinggal 3 by 3. Now 6 to D6 is not 0. So whatever value at position 6 kena kali dengan the value. So dekat sini. Okay. Saya copy balik yang ni. And then sini also. So we get new. Actually the same except kita tambah. Okay, this one also. Sekejap. This one also. The same thing. Except kita tambah yang 6 punya ni. So 6 punya ni is yang ni lah. Sini. Okay, then yang ni. Satu lagi 0. Okay, kali dengan 10 over EI. 10 over EI. Okay, nampak tak? So that is the process. Tapi tak payah tunjuk. Yang semua ni lah tak payah tunjuk. Dia you kena imagine. So yang the one that you need is at position 6 only. Because 6 you nak kali dengan D6. 6 nak kali dengan D6. Okay? So yang ni is additional lah. This is additional. Yang mana tak ada dalam atas tadi tu. Okay, yang mana yang tak ada dalam atas itu dia ada kat sini. This is additional whenever support settlement is given. Okay, support settlement memang every semester masuk exam. Every semester masuk exam support settlement. Cuma tak tahu dekat mana. Cuma tak tahu dia dekat flexibility method ke, dia dekat stiffness. Tapi memang masuk exam. Support settlement. Okay. So, additional ni, cuba calculate balik. This additional value come from support settlement. Okay, so dapat apa ni? Negative 0.1875, 1.875, it is 1.875 kalikan dengan plus dengan 60. 61. Kan? Dia lah 61. Negatif 61. Betul eh? Get negatif 61. Betul tak? 875. Okay? Is it correct value? 3.75. 3.75 plus 40. 3.75 plus 40. 43.75. Negative. Okay? And then berapa tu? Negative 410. Betul tak ni? Then you will get the new value. What is the value? Okay, please calculate now and give me the answer for D1, D2, and D3. Okay, please calculate now and give me the answer for D1, D2, and D3. Okay, please. Somebody calculate for me D1, D2, and D3. Because after this, we want to compare the vertical reaction at D before and after support settlement. Cepat. What is the new D? Please calculate. Cepatlah, sakit tengkok lah ni. Cepatlah. What is the answer? Selagi tak bagi, kita tak end the session.
D1 negative 43.450.
Negatif?
43.450.
450 45. Okay, negatif 43.45. Negatif kan? Okay, D2?
36.389.
Positif
Positif.
36389. Okay. Okay, D3?
Negative 205.95.
205.95. Okay, can you see the difference? Sikit je. Kalau D1, D2 lah. D1, D2 sikit je lah. Bukan. Kalau D3 sikit je kan. Ni 206, 209, 206 dengan 205. Betul Okay. Sikit-sikit lah. Banyak-banyak tak kisahlah kan. Tapi kita nampak ada difference tu. Okay. So ada changes. Means ada changes. 43, 42, 37, 36. Sikit je tak banyak. Okay, sometimes position tu main peranan lah, position. Tengoklah, kadang-kadang mungkin saya letak dekat A. Yang ni saya rasa macam nak letak dekat C. Okay. Means that setiap each position kita boleh check. Kita boleh set lah kalau settlement dekat A, ada changes tak dengan settlement tu dekat C? Ada changes tak kalau settlement tu dekat D? Kan kita kan ada dekat kalau in terms of vertical 4, 6, 7 ni kan. So vertical display support settlement ni bukan hanya Y Support settlement ni Z pun boleh. Dia jadi rotational. Dia rotates pun boleh. Okay. Tapi dia akan cakap clockwise or counterclockwise. Okay, kalau yang settlement biasa Y at 4, at 6, at 7. Boleh juga letak dekat 4, dekat 6, dekat 7 for comparison. Normally yang comparison ni kita buat masa buat FYP lah. Kita tengok comparison. Kalau settlement dekat 4, ada changes tak? Kalau settlement dekat 6, ada changes tak? Kalau settlement dekat 7, ada changes tak? And sometimes, soalan-soalan difficulty level 5, level 6 dalam exam, dia tanya benda-benda ni. Apa efek kalau settlement dekat 4? Apa efek kalau settlement dekat 6? Apa efek kalau settlement dekat 7? Okay, so kat mana yang berubah? Dekat yang kuning ni. Dekat yang kuning, masih lagi 10 over EI tapi dia berubah tempat. Dia mungkin dekat 4, dia mungkin dekat 6, dia mungkin dekat 7. 7, dekat 6 lain. Dekat 7 lain. Okay, dekat 4 lain. Okay, so ada changes kat sini kan. So with this value, kita boleh calculate balik nilai ni. Okay. So from this, mungkin dia punya changes tu tak banyak lah. Dia punya changes tu tak banyak. Okay, it is 375 D3 and D3 is 205.95. Okay, plus 0. Okay, yang ni at 7 kan tadi. Okay. At 7 375 ni kali dengan sama je the same process, cuma kita tukar nilai D3. D3 now is negative 205.95. So dapat apa dekat sini? Q7? Not much changes when settlement is located at C. Okay, what is the answer? What is the answer? .375 kali dengan 205.95 plus 0. What is the answer? But maybe vertical deflection, maksudnya bila kita buat ni, exercise ni, okay, ini soalan saya minta vertical reaction dekat D. Soalan boleh tanya moment dekat D. Mungkin moment dekat D changes dia banyak compared to the previous. Maybe moment dekat A. So macam-macam soalan tu boleh pusing macam-macam. And jarang dalam soalan exam, kalau ada 5 unknown reaction, 5 ditanya no. Normally 1 or 2 only, because if 1 or 2 you can give the answer, means that you understand. And 5 kali pun you akan boleh buat, 1 kali pun you akan boleh buat. Okay, because exam ni kita nak tengok understanding, your understanding. Okay, bukan hafal lah, tapi yelah kan, kalau hafal you cannot remember everything lah. Memang ada certain part yang mungkin you have to remember certain part only, but not all. You cannot remember all. Cepatlah jawapan dia apa? What is the answer? What is
77.231.
77.231? 77.231. Okay, so not much changes. Tak apa. So at least we prove. Kalau tak ada changes pun, we prove that there is no changes. So that is called the study. Okay, so normally kalau FYP konsep dia macam ni, kita akan set parameter tu berubah-ubah. So kita pun tak sure ada changes ke tak ada changes. Okay, and kita kena prove kalau ada changes, how we get the change, how we get the value. Kalau tak ada changes, how we get the value. So even though the changes is not much, but we can prove that bila settlement occur dekat C and tengok pula pada reaction dekat D, tak banyak changes. Then okay lah, means you understand. Okay, the concept behind stiffness method, the theory dia, okay, the principle of the support condition and so on lah. Okay. Sebenarnya tak panjang pun. Okay, so yang sampai sini without support settlement. Okay, and then additional support settlement yang ni. Bukan yang matrix yang besar tu, but yang 1, 2, 3 yang last tu je. Okay, remember yang ni is not for you to write during examination. Okay, it's not for you to write during examination. Tapi you have to be able to imagine. Macam mana nak imagine? You have to do regular exercise. Regular exercise. Okay, please do regular exercise and you will find that it is actually quite straightforward. Okay, kalau you buat 5 kali soalan ni, nanti you buat balik soalan lain, you dah boleh buat dah. Buatlah setiap hari 1 or at least 2 hari 1 and you continuously doing this until examination. Okay. So 2 questions will come from stiffness method and 2 questions will come from flexibility method. Okay. So in examination, confirm ada beam. Confirm juga ada thrust. Semua type of structure akan appear dalam final exam. Cuma tak sure dia dekat topik mana satu. Either it is flexibility or it is stiffness. Okay. So tengok trend pada past year's exam paper. Tengok trend pada past year's exam paper. Okay, pergi buka tu website tu. Okay, check past year's exam paper and tengok dia punya trend. Okay, and the solution is just like this. Okay. So even though jawapan dah ada kat sini, I want you to submit. I want you to submit and this is the link. This is the link. Tengok berapa orang je submit. 1, 2, 3. Yang ni 1, 2, 3. About 40 minutes Ini je ke yang sempat buat? So, ini yang submit, yang tak submit? Okay, so even though benda ni dah ada dekat sini, I want you to submit as proven that you buat lah. Okay, as proven you attend this session. Okay. Okay, please submit by tomorrow. Okay, complete this and submit. Okay, that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
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 Thank you, Doctor.